Okay. Yeah, there we go. So the title of this talk is Building a Kubernetes CI in 30 minutes or less. But if anybody who follows the drama on Twitter saw this, this is Ralph Squillaci, who is my peer at Microsoft, pointing out that my title is indeed a lie. I will take 30 minutes to show you how to build one in 5 minutes or less. And tragically, he's right on that. So story time. This is how I expand out a 5-minute talk into 30 minutes. I was working at a large media company in New York City. And I was on the software development team there. We were responsible for building some websites and then building the underlying technologies. And then we would bundle all of this up. And then I worked with the DevOps team who would then deploy all of our stuff to production. It was very high traffic, which meant deployments were very high stress. So I liked these guys. I was under the impression that they liked me. And one day, the head of that DevOps group says, "Hey, Matt, you want to go grab a cup of coffee?" Now, I should have immediately recognized this for what it is, but I'm not the brightest bulb. And so I'm like, yeah, sure. So then he takes me to Cafe Grumpy. Again, that was a perfect intro because I'm a coffee snob, and Cafe Grumpy is kind of like a mecca for coffee snobs. And so that should have been like the second clue that something was amiss. And then, he bought me a $12 cup of coffee. Not like a latte or anything. It was a $12 cup of coffee. So this is like, what should have been going on in my head was like, this is going to be one of those nasty breakup kind of things, but I was clueless. And he sits me down and he says, "So, how's the coffee?" Good. "I wanted to talk about our recent deployments." I'm like, yeah, sure. Still not picking up on what's going on. And he says, "So you remember about a month ago when you guys delivered the tarball to us and we went and we deployed it, and it turned out that you guys had been using an Apache module in dev and hadn't told us about it, and we hadn't installed it in production?" And I'm like, "Oh, yeah, that was kind of embarrassing. We had a little outage there, didn't we?" He's like, yeah. Then he says, "Do you remember how 2 weeks ago when we did that deployment, we installed everything on the production cluster and it didn't work because it was missing a library?" And I'm like, "Oh, yeah. We usually put that library in the system path and not bundle it in the..." Like, yeah. And then he says, and remember when you updated the memcache driver in dev and it was incompatible with the version we run in prod?" And I'm getting kind of uncomfortable and I'm going, yeah. And then kind of the defensive reflexes kick in, right? He's like, "I think we have a problem." And I'm going, well, my job's the developer. I'm not the operator. I'm the developer. It's your job to run this stuff in production. I'm just supposed to get the code done. And at that point, I kind of realized the absurdity of my position. And there were two things that kind of bubbled up here. And the first one was, I realized that we had a technical problem in the handoff, the exchange between us, and that's what he was telling me. But he was telling me something else. He was telling me, this is not just a technical problem, right? This is a people problem. People on that side are mad at people on this side. People on this side are irritated with people on that side. And things are getting uncomfortable, and feelings are getting hurt. And we might be able to get everything back up again in 5 or 10 minutes, but there's some resentment building up. So he took me out to coffee to explain this very clearly. That was about 12 years ago. And that moment made a really big impact on me. Because I realized that, there's one particular interchange that was going on that was failing. And that kind of interchange happens in all kinds of different companies, right? That developer to operator, dev to SRE kind of transition can be rocky. And when it does, it introduces animosity. It makes your daily work life just a little bit worse, right? So this is a people problem and a technical problem. And it looked like the kind of problem that we could solve with a little bit of technology, right? Because it was technology introducing the problem in the first place. That got me kind of passionate about the stuff that we do now today, right? And this is why I like Kubernetes, because I feel like one of the promises of Kubernetes is it gives us sort of a base level platform. So, it used to be that you travel from one shop to another and their whole method of doing the dev to production and what production boxes look like was all different and all buried behind different shell scripts and all kinds of stuff, right? Now we have kind of a common platform, and a lot of us in the DevOps world are going, yeah, this is very promising. We like it. We're willing to roll this out in production. It's useful. But the developers are still kind of left behind. And from a developer's point of view, Kubernetes is big and complex and full of jargon and YAML, right? And so my team here at Microsoft has been kind of getting passionate about trying to figure out how we can solve this problem to make the developer to DevOps transition kind of a pleasant one. And the current emphasis that we've had has really been on kind of improving the developer side of things. So I want to introduce a couple quick terms that will help you understand kind of that we kind of appropriated these, so there's nothing novel about them. But these are the terms we use in our kind of go-to how we describe the problem set. We talk about an inner loop and an outer loop for development. And the inner loop is when you're sitting in front of your laptop coding, right? You're looking down at your screen, it's you versus code, right? And so you've got a new feature, you start coding away. At some point you think you're at a relatively stable point, so you build the code. And if the code builds, then hopefully you remember to run the tests. And if the tests pass, then you spin up an instance of it locally and you start testing it, right? You point your browser at it, poke at it a little bit, look at the logs, maybe you spin up your debugger, and it's you versus code, right? And it kind of goes around in circles till you're done, and then you say, okay, feature complete, and up it goes. Then you've got the outer loop here. And the outer loop is where the CI layer lives, right? So we've got a piece of team code, right? It's no longer my code on my computer, it's the team code, and it gets built. Then we run tests on that, but the tests that we're running on that are a different kind of test often, right? We run the unit test, but then we're running functional and integration tests and sometimes style checks and things like that. If it passes the test, then we package. We build an artifact, and we put the artifact somewhere where you can get to it. And if we're the CD kind of place, then we're also deploying along with it, and then we're verifying that the deployment goes well, and we finish that loop, and then we start again on the next batch of software, right? Now we combine these two, and we get this kind of overlay view of how the life of the developer and the development team kind of works together. We're doing this inner loop, and at some point I go from this is my code to the magic git push in which I say, it's not my code anymore, it's our code. And that means it's not my failures anymore, it's our failures, right? When CI goes down and your tests flame up, then it's our problem, not my problem. And so that's, why is this thing going on? So that's kind of the set of patterns that we tend to use. Now we looked at that and we said, okay, that gives us a metaphor that we can use when we develop tools. We want to build some tooling for the inner loop and some tooling for the outer loop. And we feel like if we can do that, then we can accomplish what we're after. So the first tool is Draft. Draft is the inner loop tool. And it's a tool for rapidly building applications that are container native, right? So we don't want to have opinions about the languages or anything like that. We just want to build that inner dev loop in a way that streamlines the experience so that the developer can get their code up into a Kubernetes cluster. The key insight here is, you know, the cluster, typically you've got Kubernetes here and then you've got local Mac here, right? Or local Linux or Windows. There's a big disparity in what these environments look like. We want to bring the disparity down. We want to have the local development environment be approximately the same as what the production environment is. That we think is going to solve a lot of problems. But that means you have to make it dead simple for the developer to get there, which is not going to start by telling him to go read Kubernetes the hard way. It's going to start by saying, we'll bootstrap it for you. This was the brilliance of Rails, right? We'll bootstrap it for you. You can get way into it, and then we'll walk back and explain how it works. So this is how it looks, right? I do a draft create on my source code. It scaffolds everything out, builds me a Helm chart, a Docker file set up with whatever language it auto-detected. It prepares everything for me. Then I go and edit on my code and hack away, and then I type draft up. And when I type draft up, it goes and it builds my Docker image, pushes it to a Docker registry, installs my Helm chart into the cluster that I've configured, and I type draft connect, and it says, here's your URL. Your dev server might be a Minikube instance locally, might be OpenShift or AKS or whatever, but it doesn't matter to the developer because you're still just hitting localhost and some port on there, and the experience feels very local. Feels very comfortable. You know, I'm still using all my editors, all my tooling, but we've managed to bring the level of disparity into just about parity, right? Ooh, that was a really bad rhyme. That was our inner loop tool. Our outer loop tool is called Brigade. So here's what we were after. We were looking at the way that Linux and Unix and systems like that managed to get successful. And part of it is they made it possible to build complex stuff out of a bunch of simple components. So you've got executables, and then you've got a scripting language that allows you to put some workflow around those executables. So I can do foo -- bar, or I can do, you know, foo -- bar, pipe the output to something, check the values. If I do this, then launch this, otherwise do that, and I can start building up some scripts. We said, what would an experience look like in the cloud if we, you know, in Kubernetes, right? If we could say, here's a script, but instead of operating on executables, it's operating on containers. So run this container, grab the output, depending on that output, run this other container, or maybe run that one, or notify me of this case, and script it up just like, conceptually just like a bash script works or something. And that's what Brigade was. Brigade is. And so there are a couple high-level ideas here. Essentially, we borrowed the event model from AppleScript. And if anybody written AppleScript? The idea is you declare, hey, this script handles this event and then does this stuff, right? And so we followed that model. So you declare this script handles a GitHub push event. And then you write your script in there. And then when a GitHub push event happens, comes in through your gateway, and I know Luke's going to talk about that later, and it triggers a new build. And then it walks through and executes your JavaScript. We picked JavaScript because it's a language everybody knows whether they like it or not. And it starts up a worker, executes the JavaScript, which can then start jobs that are running those containers, and it pipes data from one to the other, and you can parameterize things. And it feels like a scripting language. Turns out that a CI system is approximately a proper subset of this kind of thing, right? Define a workflow, tell me what the entry point is, and run it to completion. And so we began using it as a CI, and ultimately that became the easiest way to explain it. But now somewhere along the line as we did this, we started questioning all of those assumptions with those two circles. We started saying maybe we got too rigid in the way we were carving up this problem. Maybe the inner loop is only the way the inner loop is because we didn't solve other problems correctly. What are the kinds of things that we could maybe learn from the way we parsed out stuff in the first place? And we came away with a couple interesting insights. The first one was, we are inconsistent and we often make developers pay attention unnecessarily. So we'll do a little comparison here. When you're debugging, here's how it looks, right? You launch your code and then you're typing here, you've got a window open here, you're over here, you're checking back and forth, you're running a few tests over here to see what happens over here in the log files. You're engaged, you're leaning forward into this. Then what happens when you run make test? It goes like this, make test, phone, I'm gonna go to the bathroom, maybe grab a cup of coffee. You've broken flow. Right? You're not engaged anymore. And you wait and you wait and you wait and you wait, and really the only thing you care about is whether it comes back and says your test failed. So it's an interruption. But then conversely, the second insight we had was that we often make it too easy for the developer to break stuff. Picking on testing, we rely on the developer to do the testing themselves initially, right? And to certify when they get pushed that they already tested it. But we forget. Or we avoid, right? So I was working on this project a couple weeks ago and went to do the git commit and realized that I had left a comment in there I didn't intend to leave in there. I'd already run the test, everything passed, so I just opened the file, deleted the comment line, and accidentally deleted one more character, which happened to be a semicolon that was doing its job. And so 10 minutes later, I broke the build and everybody's like, CI's red, whose fault is that, right? But it wasn't because I was necessarily shirking my duty, it was because there was an oversight and there was nothing in my environment that protected me from that, even though there could have been something, okay? Second one is that, again, this disparity idea, right? The packaging, the matching everything to the runtime environment, we tend to push that off to the CI system, right? I push up my raw binaries or my executable, and then the CI system builds the packages and puts all the stuff in it and executes that. That means that I'm not engaged in that process. I'm basically pushing off some responsibility, and it means my development environment and my production environment, I've got that big disparity, right? So another example of my failures, I was working on some code, wrote an import path, accidentally capitalized the wrong letter in one of the file names. My Mac didn't care about that because it's case insensitive when it comes to that. So I worked on it, I ran my tests, I was a good developer, I pushed everything up, CI broke. I'm like, what? CI's on Linux, and I didn't connect the dots immediately, and I'm hacking through this and going, I see the file here, I see the import path here, I see it checked into GitHub here, why is CI telling me there's a problem? It's because this disparity here bit me, right? It caused a problem, and it took me about an hour and a half to realize that it was just because I had a capital C when I didn't need one, right? Then the last problem is really that when we construct things this way, and we separate the outer loop and the inner loop this way, and then DevOps ends up being responsible for this outer loop, we start to make development problems into DevOps problems when that's not really fair. you know, in that case, if I had been working with a DevOps team, honestly, my first response would have been, hey, DevOps guys, your CI system is broken. Everything's passing locally, works on my laptop, right? The line that makes us want to punch people. And I would have shirked my duty off to them. And we see that kind of thing happen, and that kind of thing causes tension. So the outcome of this is that we thought maybe we conceived the inner loop idea wrong. So let's give it another shot. So I unwrapped the loop. I unrolled the loop. It's a compiler optimization. And kind of tried to replay this out and said, okay, so we start with the code. We got to write the code, right? Then we got to build. But instead of building my local binary, why not build the Docker image? And then instead of just packaging, I'll package it up as a Docker container and a Helm chart, and then I can push it into my cluster as part of my development cycle and have my own little dev cluster here. And then I do my debugging and my testing inside of the cluster. So I've just brought everything up so we get approximate parity. And then we made this other thing here where we said, okay, debugging is I'm not demoing yet. Debugging is a foreground task. So we need to make that a foreground task. It needs to feel like it's right in front of the developer and that they have control of it. Testing, background test, background task. We only notify the developer when the tests fail. So can we set up an environment so that the tests automatically run and the developer doesn't have to be aware of them at all until they break, and then they insert themselves in front of the developer and say, I blew up, fix me. So that's what we were going to try and do. So now it's demo time. Possibly. There we go. So here's my, my VS Code editor. I'm going to admit I'm not the biggest VS Code user, so I might stumble through some of this. So this is my simple Node.js JavaScript application. Okay, I built a fairly straightforward service. It just declares a hello endpoint and a health check endpoint, and you can see over here all the stuff that Draft created for me. I've got a chart right here, which is a Helm chart, right? Got a Docker file right here. It auto-detected I was writing JavaScript, and so it built me a chart that or a Docker file that builds all of that, and I've got a draft.toml and other things like that. So this is my workflow, right? When I'm ready, I've done my development, right? Now it's time for me to go fire up my local instance. Normally I'd run some kind of command, like for me it's make run because I'm a make kind of person. But in this case, we just replace it with draft up. So I hit draft up, and sorry, that showed up at the bottom because I didn't clear my screen first. So it's going to build a Docker image. It's going to push the Docker image somewhere. It's going to release that Helm chart as an application. Now here's what it's actually doing. I'm configured to go to AKS, which is the Azure Kubernetes instances in US East. Is that East? Whatever direction East is. And so it's running over there, and I'm using Docker Hub for pushing the images. So this is actually a remote workflow, okay? This stuff isn't running on my local box. But as the developer, I shouldn't care, right? It shouldn't make a difference to me. Then I run draft connect, and it's going to start up a proxy for me. It's going to look like it's running on my local host, but it's actually tunneling all the way to US East, where it's running the other command, or the other my code. I need a terminal. I need another terminal. And if I curl this kind of thing, localhost colon 8181/hello. Let's make that bigger. I just get my response, right? So that's the kind of development workflow I want. It feels local. And now I can go back to my editor, and I can go change something. So let's see, hello is calling this hello library here. So let's go to this hello library. Let's add something. Let's add hello again, right? And now let's go redraft up. I'm going to break my draft tunnel. I'm going to draft up. I'm going to fix my terminal so you can see it. And so once again, building the image, pushing it to AKS and everything else to Docker Hub. It's doing a Helm upgrade this time and upgrading my chart to the newest version. And you know, everything should come up in a minute or two, and it should look just great, right? So I can go along and do my draft connect. And now I'm starting my tunnel connection. Oh, that's gonna be a problem, isn't it? I'm actually just buying time. And there we go. I get my hello again. However, something interesting happened over here in Slack, and the notifications, which I disabled so they didn't interrupt me, something broke down here. My test failed. Why did my test fail? It should have, with my, it should have just boom up in the upper right-hand corner. It normally would notify me, except I muted them. Why did it fail? Well, let's see, because I changed it to again, and if I go look at my tests, then I will see that my tests were checking to make sure it was hello world. So all the testing was done in the background. And in the ideal world, the notification sound wouldn't have been muted and we would have got ping and the little notification in the upper right and I would have gone, oh, something broke. But it wouldn't be until something actually broke that I was prompted. And so then I could go and say, all right, well, what did break? And I can go take a look at my Brigade build. And I can see, oh, okay, so this is my build. This up here shows me like the progress indicators of how long it took my various background tasks to run. And I can see the red one here is the one that broke. And if I go look at that one, it's going to show me the output of my test, and it's going to tell me, you did hello world again, the test expected this. And it's all happening in a way that's fairly easily discoverable to me, but not in my face unless something breaks, okay? So I went and fixed everything, and then I can go back and, the next step normally would be, okay, I'm gonna run my deployment. And so I would, kill this, do a git, actually in this case, I'll just do a git tag 0.1.0, and then I'll do a git push tags, because I didn't actually change anything between the demo. But now I'm exiting the inner loop process and I'm going to the outer loop process, right? So now what's happened is I've kicked it up to GitHub, and I'm going to end up with another set of tasks running. And those tasks are going to, actually I'll just show you the code because I know I'm running a little low on time. But those tasks are going to go through the whole process of running all that outer loop stuff where it's going through the other tests, and eventually it'll build a Docker image and push the tagged Docker image up to Docker Hub. But we'll look really quickly just to see what's basically happening, okay? So this is my Brigade script. A brigade.js file is where I declare that whole sequence of events, right? And here it looks, again, it's event-oriented. So we can look at this top one here and we can see, all right, I declare my script handles the exec event, and when the exec event is fired, all it does is log something, okay? Not terribly interesting, but always a good one to have there so you can test it. Now here's this more sophisticated one here. I've got an image push event. So this is set up so that when I push an image into Docker Hub pings back to my Brigade server and says, I just got an image. And so I have a chance now to act on that information and do something. So my script says, okay, I'm going to take a look at this image you just got. And if it's tagged edge, that means it's a development instance. Anything else I don't care about. If you're tagging a production thing, my dev environment does not care. But if it's tagging an edge thing on my repo, then that means it's me doing my active development. So it starts kicking off my active development stuff. This is where I'm running the unit test that we just saw fail a second ago. Okay, so here I'm creating my job. Remember we talked about jobs in Brigade are basically like those executables. I'm setting up a container, and in this case, so I'm running my container with draft up, and this is my application server running. I spin up a second copy of that same image, and I'm going to run my tests on that one. But I'm going to override it. So instead of starting up the server, I override the tasks that it start and have it start yarn test instead, which is going to kick off the unit tests. So that's how I run the tests on exactly the same artifact that I'm currently using to debug in another instance in the same container. So it goes and runs it, and if it runs it and the tests fail, it'll throw an exception. So I catch the exception and I say, send me a Slack notification that says, your test just died. Then I did another one here, and these two will actually run in parallel because of the way it's set up. You can run things parallel or serial, but I realized that one of the things we tend to push up to that outer loop cluster is functional testing. Why? Well, because usually with functional and integration testing, we need the whole environment stood up in a particularly known set, right? And on my laptop, it's really hard to have all that stuff running in a production-like way, so we tend to roll it into CI. But then that's another opportunity for the developer to kind of, wash their hands of it, and the tests tend to suffer a little more neglect in my experience. Maybe you guys are better at it than I am. Why not try and move that locally? Because now that we have Draft, Draft is standing up all the right Kubernetes artifacts for my code to run in a Kubernetes environment. So I get all the service discovery features and all that kind of stuff. So I could run my functional tests locally too. And I can run them with a very high degree of fidelity. They're going to be very, very similar to the ones that I would normally only be able to run in CI. So I wrote the world's lamest functional tests, and they're basically calling curl. They're using the Kubernetes service discovery to discover my node demo chart, and then I'm just looping through, and I'm checking each of the endpoints that I declared. And it's running, and if the response curl gets is a 200, then it's marked okay. If the response is a 400, then it throws an exception. So I can catch that exception again and say, warn me that the functional test failed. So now I've got 2 layers of testing that I just moved to in a kind of high fidelity way to my local handling. Then down here, I've got the push one. So this is the outer loop handler, right? This is the GitHub handler. And so GitHub's push event, again, GitHub calls back into my Brigade cluster and says, hey, Matt just pushed this, run the outer loop. So now it goes out there and it runs its own set of tests, and then it goes through this whole thing. I just kind of whipped one up where it checks, and if I tagged the release, then it goes and does a Docker build. And then it takes if we look at the Docker build function here, we can see I'm running Docker in Docker on a Kubernetes cluster. I log in using some of my secrets. I run my build, and then I tag that build as the latest build, and then I push it all to Docker Hub. And so basically, I'm walking through that outer loop, and I've just hit that point where I generate my artifacts, and I push them up there. So now I can say, hey, DevOps guys, here's the last tagged image. This is the one we're going to work with. We can automate CD really conveniently because all we need is to make sure everything can access the same registry. And the whole idea there is to try and streamline this stuff to the point where that frustrating stuff, didn't get this module installed, don't know how to package this thing, you changed something here, that stuff should go away because the container itself is wrapping all that kind of information. And as long as I can run it on Kubernetes and they can run it on Kubernetes and our Kubernetes are approximately the same, which is supposed to be easy, then we end up in a pretty good situation. Okay? So I'm not going to say this is the final step, but you can kind of see how we were trying really hard to get to this point where there's less and less tension between the developer and the DevOps team, right? Or even between the developer when they're in developer mode and the developer when they're in deployment mode. So here you can see kind of like, this is the outer loop we just ran. This is the inner loop that we just ran. It's a little more complex than the usual. And that was the idea. If we can do this well, and we're still striving for it, right? But if we can do this well, that situation from the beginning should start to get resolved, right? There's less conflict between the two. The handoff between DevOps and developers should be easier, right? We should have an easier common language to speak because we agree on what the artifacts are supposed to look like. They're Docker containers and Helm charts. So that's what I got. That's the kind of stuff my team is passionate about. Normally I'd take questions, but I think Luke should probably go next because he's also going to talk about Brigade, and then we can field some questions together if that's cool with you. All right, thanks a lot. Oh, yeah, you might want a mic. So we're not doing that thing where I talk on the mic while he's going and like offer a running critique.
Yeah. Do you hear me? Yeah, cool. All right. I'll go ahead and get started. I'm Luke Phillips, and I'm going to kind of continue the theme on Brigade. I think Matt started us off with a great kind of need for maybe I need a story time kind of moment here. How did I get into Brigade? I got into it about 6 or 7 months ago. I think Brigade's been out for a year or so, but I stumbled upon it about 6 or 7 months ago. And where I work, I'm at Charter Communications, a part of their network architecture team, and a lot of people that don't do a lot of software. I'm trying to help them with software and teach them about this wonderful world of orchestration and platforms and things like that. And so they know there's Kubernetes and they know they want more Kubernetes. So I say, hey, there's this cool project, Brigade. It does this event-based scripting on top of Kubernetes. They're like, well, okay. It's like, well, it's cool with this ephemeral framework. It gives you kind of this functional serverless feeling, and they're still kind of glazed over. It's like, well, have you used Jenkins before? It's like, oh yeah, we know Jenkins. Like, yeah, I can build Jenkins-like things. We have all these Jenkins jobs. I can bring those jobs into Kubernetes, and Brigade is kind of a way to facilitate that. It's like, oh, okay, great. It's like, but internally, we're not using GitHub. We have GitLab and Bitbucket repos. So for me to be able to demonstrate internally those integrations, I need to build that. So I kind of like, well, I could do this really cool stuff for you, but you're gonna have to give me a little space to go extend Brigade into being able to work with these other sources of events that aren't the ones that come out of the box with Brigade. So that luckily gave me a lot of space to dig in more into Brigade, get involved, and convert over like Jenkins jobs and things like that. So it's been exciting, both being able to use that as a way to communicate more kind of Kubernetes and scripting frameworks to my group as well. But when you're looking at Brigade, it's kind of the point of my topic today really is how to extend Brigade. And so my discussions and what we're going to get more into some of Brigade itself, talk about gateways, secrets. I'll walk through the code of one of the gateways I've built for GitLab. And if we have some time at the end, I'm also going to talk about an example of some persistent storage, a Minio example, as far as storing things that you do in Brigade, because most everything in there is all very ephemeral. So how do you keep anything that you want longer? So what is Brigade? From Matt's presentation, I'm sure you are all now Brigade experts. It was kind of a quick buzz and high-level componentry. Even though I've not been involved in the creation of Brigade, Matt's team are the ones that have kind of created all of that. So if you need the deeper technical reasons of why is Brigade the way it is, you can check with them. But beyond that, I can help kind of ephemerally. More where I've been is in the gateway space. So here's another view of a Brigade architecture. If you haven't seen this before, this is kind of how things will flow through. You have some kind of event, like Matt was talking about before, where he had Docker Hub and GitHub examples. Those are the gateways that ship with Brigade. Brigade is made up of many pods, so it's all packaged together in a Helm chart with up to, I think, like 5 possible pods inside of it. You have like a GitHub gateway, you have the controller, you have an API, then the workers and jobs, they're not actually running until an event comes and needs them to run. So that's just kind of cool where you get into that kind of serverless or functional mindset where there's not infrastructure waiting for work to happen. Infrastructure gets built up, worker pods and jobs spin up based off of your project, your Brigade script, and your event. They build up, do all this work, and then tear themselves down. If you, in your workers and your jobs, if there's any artifacts that you're building or anything like that, you might want to store that off. So again, if I have the time at the end, we'll talk more in depth about how to do persistent storage using a job to write that out. But really what's more important is how do we get events coming in? So myself, I needed to solve the problem of I needed to listen to GitLab or Bitbucket events. So we have our internal repos. People are checking in codes there. We have pipelines around those. So how can I listen to that? So the gateway itself, gateways are very simple relatively as far as they're typically, say, like an HTTP listener. You expose some endpoint and you're going to take a request that comes in like a GitHub webhook or a GitLab webhook, and you'll translate that to whatever logic relative to your gateway, and then you're going to write out an event, which turns into a Kubernetes secret. So it's just kind of doing that translation, writing out the secret, and that's mostly all the gateway needs to do. There's just a ton of things out there that we could possibly integrate to for events. Even though we have these Git examples, we could do other things like, say, Trello or Jira events. Slack, I think Matt might have some experiments on having a Slack bot, instead of just writing out to Slack, be able in Slack to say a message, do a build that could send an event to a gateway. And I'm sure many of you as well know of many various APIs and various platforms you're all familiar with. So likewise, kind of what we're looking for is how do we get more people committing or building up more gateways so we can really make Brigade able to do a lot more cool integrations and effects. So more in depth about the gateways themselves. I've said kind of the first couple of points. Other examples, there's also the Brig CLI tool, which you kind of saw for a moment there in Matt's demo, but the Brig CLI tool also writes events, so that makes it itself a gateway. But again, really anything could possibly be a source of events, so we're kind of looking for your own ideas as well. How do we integrate out to other things like that? So anything that you might have an idea for, by all means, it's a great way to get involved in Brigade. So what is a secret? So let's go into Kubernetes secrets themselves for a moment. They're one of the many primitives available to you in Kubernetes, much like a deployment or a pod or a replica set, things like that. They'll exist in the namespace. They're not tied to a specific pod or to a specific deployment, but they are available to your pod and to your container, either as a volume mount or as environment variables to the container. They're pretty lightweight, megabit in size. We'll kind of see that as we get further into the code of writing a secret. You're kind of limited in how much data you put in there. And all the data fields are going to be base64 encoded, even though in a lot of the examples I'll kind of show them already as clear text, just to make it easy to read through. But everything you store in there, base64 encoded. Here's kind of your sample secret. This kind of a YAML layout. You have your secret, basically two major components of data: the metadata, any set of key values for your labels, a name, just something unique, and then data, your own set of key value pairs, the values all being base64 encoded. So you'd create a YAML like this, kube control create. You have your secret written, and you can do like a kube control get secrets. You can pull the secret out. You'll see the base64 encoded data strings. And if you want to decode, you can just pipe that into base64/d, and you'll see, oh, my password is Boulder. So that's a secret. Are we good with secrets? Basic layout, cool. So what is a Brigade secret or Brigade event? All events in Brigade are nothing more than secrets. They're just specially labeled. That's all the magic there is to it. So here's an example. Brigade secret. I'm going to go through a couple slides. First, the metadata components. You define a standard secret. Metadata, a name, you just have to create something unique. And labels, Heritage Brigade, that's the magic component there. That's what makes the secret in a Brigade event. So as long as you have that, you're good to go. The other useful metadata that's also needed is a project ID. So in Brigade, you're going to install your project, which contains your Brigade script, your Brigade.js. When you install that, you're going to have a ID. So you just, when you're writing your secrets, you'll have to query your projects, query Kubernetes, get your project ID put in there. Build ID is just a unique value, can be UID, ULID, something unique. And then component and type, these are just standard keys for the Brigade event. And then we'll get into the data fields. Not all fields here are required. It's going to be relative to your gateway and relative to the projects that are going to listen to your events. This is the all of the possible data fields you'll need. Event provider, this is typically going to be, say, the name of your gateway. So if you built like the GitHub gateway, mine's will be GitLab or Bitbucket. All of the fields in the data will be available in your Brigade worker. So when your project kicks off, it's going to be handled in a worker pod, and that will have all of this data available for whatever parsing you want to do for whatever logic you want in your project. An event type push. This is the event you're going to be listening to in your Brigade script. So whatever string you put in there, this is likewise you want to communicate that out for whoever's developing the project script. Like we saw before with the other examples where you had push, or you had like the Docker push events, or the exec events. The revision object, you're just going to talk about if your project has a Git sidecar associated with it, where it has to go clone a repo to go get your project script. This is where you describe if it needs to particularly check out in a certain branch or a certain commit, you can pass in along that information. These are the same fields we saw before in the metadata, so you just bring them down here as well. It's the unique build name, project ID, and build ID. A payload, this is just an unparsed string. Typically, say like with the GitHub or like the GitLab gateways, those are web service post events where it's going to be a large body describing what happened in that commit or in that push request or something like that. Typically, you just take that body and drop it in here if you want to make it available for the developer. And then script. This can be your Brigade script itself here, so the event can push its own Brigade.js script along if it's not going to go check one out from some repo. So that is the Brigade event, Brigade secret. We're kind of good with the layout there. So now we'll be able to write our own gateways. I'll kind of go through the GitLab gateway that I built here. You'll be able to find it here. And I also have Bitbucket as well. I'm going to go over just a few key items in the code that I wrote there. I'm not going to go through all of the code itself. That'll take a little while. But it's really basic itself as far as you're writing, again, an HTTP listener. So you just have a simple method to spin up a HTTP listener, and then it's going to have some handler, and then I'm going to pass it off to a helper function that's going to go write my secret. So just a couple, I did this in Go, so a couple Golang packages, and you're off and running. So I'm defining my gateway executable. Kind of what's key here is I've defined a path. So I'm setting up my HTTP listener, and this is my whole main method. This is all it really takes to get running here, where I've defined my webhook is a wrapper around the Golang HTTP listener, and I've simply supplied it with this hook object that I've defined, which contains my handle method. So any HTTP listen event here goes to the handle, and then I've merely myself defined a bunch of constants here to make it easy to do other logic along the way. And for your HTTP listener, you've got your base, your port, and your path. And so that's the basic HTTP listener setup for this. And then from here, let's look at the initial handler. This is the logic in your gateway that starts to parse. All right, here's the web service event that's come in. How do I handle that? I just have a series of switch case statements, pretty straightforward at that point, where I get the entire release as the whole payload body, parse it out to get my commit information, the repo name, use the repo name as my ability to go query the projects that I've installed in my cluster, and I've simply defined push as my event string. That's kind of your rough logic there. And this goes off to my handle event method, which then is going to be the helper to go do the secret writing. Part of the reason I started this in Go, since Brigade itself is in Go, I could write the code. I should probably start back. For any gateway itself, it can be written in any language. It doesn't have to be in Go. Anything that you can define HTTP listeners, if that's related to your type of API or gateway that you're working on. Ideally, probably any language that has an SDK for Kubernetes, just something that can help you get running for writing Kubernetes secrets. I just took yet another shortcut by using Go, because then I could just simply import the core Brigade library and then just reuse their secret writer code. So it kind of gets you running pretty quickly there. So this is all it takes. The code up above just handles some basic security and some logic around, did I find a project with this matching name? So assume the security in project has passed, and so I'm going to go build my secret now with the project ID, the event type, which was that push before. Since it's my GitLab gateway, that's I'm going to call it provider, and a payload, which is just going to be that whole post body. And it will then write the secret. Create build in the Brigade terms, but it's writing a Kubernetes secret at this point. This has 5 of the data fields out of the, I think, 8 that I showed as an example before. So again, not all of them being required, but these are the ones relevant to how I designed the GitLab gateway. So let's watch the gateway in action, how about? Can you see these okay? Yep, right. So I've got a cluster running with just the core Brigade pods, basically a controller pod and API pod. That's all that's running actively. And I'll go to the GitLab repo. You can see the rest of the project structure. You've got Docker file, my server, the HTTP listener code, the helper package, a chart to wrap it all together with. So you can come here. This will talk you through completely from scratch if you haven't run Brigade before, and the steps. Make sure you have Kubernetes, Helm, Brigade, and then from there, you can either, to install this gateway into your cluster, you can either clone this repository and simply do the Helm install on the chart file in here, or you can add the repository as a Helm repo, and we'll just take advantage of that. And so I'll go into my cluster, install the gateway. Gateway is coming up. And I'm just going to steal that real quick. So I've got the gateway up and running. Let's go ahead and watch the logs here. So we can watch the logs on the gateway. You can kind of see down here it's up and running, listening on the internal 7746 port on that path. And once you have that set up, you would go typically to your GitLab, go to your repo, and go to your settings, go to your integrations, and here you'd provide the URL path to your Kubernetes cluster to the port that the gateway is available on the path, and then put in a secret token relative to the project that you install. I'll go down here and show an example of one that I've set up before. So this is just out to some host I have out there publicly, to a node port, to events GitLab. So this is where GitLab will be posting these events. This is my very secret token I break for sea beasts. And you can subscribe, choose what events you want GitLab to send. The gateway that I've built is able to manage all of the events. And yeah, you can hit test, send off events here. You can see what events look like from GitLab. What's key is the headers where you have your event, and here's the whole body that comes through. So rather than tempt the demo gods with routing the network all the way into my cluster here, I will just kind of poke at my cluster locally. Just drop this off here. So I've got Postman, just a quick and dirty tool for being able to make web service requests. I mock up. Essentially, here's what a GitLab request looks like. Here's the headers. Here's the full GitLab body. And actually, let's just mess with it. Let's, instead of a push hook, we'll do a foo hook. And we'll go back to our gateway here, and we'll send the request, and it received the request, parsing the payload. Unfortunately, there's no event foo hook, so it rejects the request, and nothing happens in your Brigade cluster. So let's go fix that and go back to push hook. Send this off. Interpreted it, got all the way through up into it, hit the security and project where it couldn't find a project called Minio Brigade. So still no work being done. So let's add a project. Let's add a Brigade project to the my cluster here. So this project that I have here, this is a sample Brigade project I threw together that kind of brings together various components where it demonstrates the storage capabilities both in Brigade and then as well outside of Brigade, doing persistence. Inside of Brigade itself, the jobs have the ability to attach to some temporal persistent volume claims, and as long as the jobs are, as long as the worker is up and running, those claims will be there. But once the worker is done, they're all cleaned out. So from job to job, you can share data between them, or they can share basically the same file amount or volume amount, and so you can share data that way. And then this demonstrates as well a final job that will take that data and make a S3 push of that data into an object store. I don't think I'll have enough time to really get into the depths of how all the storage works, so if you want to check out the project, it'll walk you through what it takes to manage all of the storage. So we'll just kind of quickly get the project installed into my cluster here. You see, we'll do a Helm ls real quick. We have got Brigade, we've got a gateway. Now let's add my project. And you'll also happen to notice the projects themselves are yet another type of secret in the Brigade world, just a Brigade project style secret. So now that we have a project called Lukepatrick/Minio Brigade, we should be able to go back here, send the webhook experience, and we see a worker spinning up, and then it's spinning up another simple data job. So this is a job that's going off just making dumb data, writing it out to some files, and then a Minio job is going to go read the files from the previous job and write that to an S3 storage example. Minio being a way to run an S3-like experience locally. So we can go verify. And Minio, refresh the page here, go to our Minio browser, and we should see here at 7:30 a new file was written. And we can take a look at it, nothing exciting, just debug information being dumped out. But yeah, that's a custom GitLab gateway. Yeah, those are the references, links, questions. That's all I have. No. Yeah.
I've given Matt a hard time. Where do you start with your own gateway, right? I
Yeah.
want a gateway to everything. I want a gateway for my Nest and my house. I want a gateway for S3. I want a gateway for Spotify, right?
Yeah.
What was your experience with coming up with your own gateway?
I think I kind of look at it first. Could I just basically understand a HTTP listener, not thinking about a gateway, but just could I interact with an API of some sort, listen and interpret, and then, all right, what's the other half? How do I write secrets? And then how do I marriage those two things together? That was kind of the experience I had. Luckily, wasn't too bad as far as doing something like, say, GitLab is a very well-known API out there, so there's lots of insight documents, other experience you can get from that. Figuring out how to structure a Brigade secret, that took a lot of interaction with Matt at first, but the documentation for Brigade is really coming along pretty well, so hopefully easier for more and more people to get into it. And I think as more people contribute gateways as well, hopefully that builds up more libraries of here's easier ways to get started.
And based on your feedback, I decided that I needed to make it easier to write gateways. So I wrote a project that basically uses Draft to scaffold out a full gateway, and then all you do is you fill in the URL path and the right data that you want to get passed through, and it does all the rest for you. Because I figured you're right. Nobody should have to wade through basically nobody should have to do as much work as Lucas did to get their first gateway running. So I think it's just about done, and I'll try and post some links out there on the Slack channel and places like that. But it was, it's inspirational to see this kind of stuff and then go, well, wait a minute, if we can just lower the bar a little bit, then it should be trivially easy to create these kinds of webhook to Brigade gateways. So working on it based on your feedback to try and make it really dead simple to do this kind of stuff.
I think the big aha for me once in Brigade was understanding that essentially secrets are the message bus for Brigade. Going, all right, that's how things are going between the various pods. All right, now I see that component, and I'll just add my message into that. So, in the back.
I will repeat the question. Yeah. So the question was, man, that seems expensive. No, the question was, if you end up doing a lot of the development in your Kubernetes cluster, you just end up running up a really, really big bill. And the answer to that really is that you can run up as big of a bill as you would prefer based on your preferred method, right? So what I showed was me running this against an AKS cluster that's running somewhere on the East Coast and Docker Hub and stuff like that. And I'm going to admit that part of the reason I showed that was because I think it's super cool that it goes as fast as it does even when you're running like that. And I'm also going to admit that I work for Microsoft, which makes AKS. And so consequently, when you run up big bills, it pays my bills. But to be honest with you, in my day-to-day development, I do it all on Minikube. And I'm running, so I have a Minikube script that basically starts up Minikube and pre-installs Helm and Brigade, and then I run that script every morning, and then I point to my local dev environment and I run it all there. And my Minikube environment is close enough to my AKS production environment that the transition between the two is fairly easy. So there are advantages to running in cluster because then you can get public IP addresses and you can do triggers into your public IP addresses. And so for a lot of these like custom gateways, you can do some really elaborate stuff. But if you're more interested in close parity but keeping the cost down, then you teach your developers two things: how to install and start Minikube, and then how to use the rest of the stack. And you can find gradations in between, right? So one of the features, and I swear I'm not selling this, I'm just explaining this. One of the features in Azure is you can do these ACI things that basically spin up a container, and it looks like a Kubernetes pod, and you run it and you're billed by the second, and then you tear it down when you're done. So for something like Brigade, where you might be running 9 different containers for a sum total of a minute, that can be a lot cheaper than running a cluster with like 5 nodes on it that are just sitting around idle waiting for things. So you can kind of play the cost control game fairly effectively with these tools if you're willing to spend a little bit of time figuring out kind of, what your thresholds are as far as how much public traffic you want in versus what your thresholds are according to your credit card limit, right? No, it's actually engineered very specifically so you can share one. And you can divide it up in several different ways. You could run multiple ones in the same namespace and things like that, but that's probably not what you want to do. The most common pattern we're seeing is that a team with 5 developers might set up like 5 different namespaces, and so every developer gets their own Kubernetes namespace, and then they're deploying into their namespace. And then you get kind of all the security advantages of the namespaces, and if you're using RBAC and things like that. So you can kind of segment it off. So then when I log in and look in my namespace, I see just my stuff. When you log in your namespace, you see just your stuff, but we're really only running one Kubernetes cluster. Yeah, and 5 nodes can effectively perform the duty that would otherwise be 25 nodes, right? So you definitely Kubernetes gives you that nice density advantage, where because and Brigade and Draft are both kind of helpful in the sense that they're not consuming a lot of resources. Brigade's setting something up, running the necessary stuff, and then tearing those pods back down. So you get a higher density for number of nodes versus number of things you can run on those nodes with that kind of setup. So which is a good middle ground to giving every developer their own dedicated cluster. Right?
Yeah.
So, a couple of questions. First one is, why secrets? And then the second one is, a lot of workflows that I've seen, it's a fork and master, or fork and upstream. So you're not really breaking it. You're not breaking the build for everybody. You're just breaking the build for yourself, and you're just blocking yourself from merging. So I'm kind of wondering, if you're using GitLab or you're using GitHub, so if you do a commit and then you push everything off to Brigade, does Brigade have a way to push things back to say, okay, this one's okay to merge?
Yeah. Okay. So there were 2 questions there. The first question was why we chose secrets over, say, a CRD or something like that. Yeah. Second question was, are there basically
If I'm going to use it as a CI, can I have 2 lines at the end with my GitLab file that says push out to Brigade and then accept that to do the merge?
right? So the second question is there an upstream out of Brigade back to something else to say this one is certified and good to go? Do you want to answer either one? Because I'll, as you know, talk forever.
Yeah. I mean, you probably, because you built that more in the GitHub gateway where
Right.
it could respond back and do that. There's less that API, at least that I have accessible in GitLab or Bitbucket. So GitHub's going to be more extensive for that kind of example. So there's that possibility.
You would be
that.
able to write
Yeah.
anything. Basically, you can call out to APIs just as easily as you can call in.
Yeah.
In some cases, you can even operate on Git itself, right? Because every pod, if you configure it, will end up with a clone of your upstream repository, and you can mutate the clone, and then you can even do a Git push from there. We don't tend to recommend that because it's a little hard for traceability's sake. Yeah. Yeah. And then the answer to the secrets question is pretty quick. We picked secrets for 2 reasons. We picked them over config maps because they obscure the data, they obfuscate the data just enough that, and hypothetically in the future we'll have actually encrypted secrets in Kubernetes, that it would make people feel more comfortable that they were storing things in something that was designated as this is something that could be or should be secured. And the second one is we couldn't use a CRD because we mount the secrets as environment variables and files, and this is how we make it so easy to work on these things. And there's no way to mount a CRD as a volume or as a environment variable. And we've talked to Brian Grant and other people about trying to figure out how we can accommodate that, because ideally it'd be nice to have a CRD. And we could say, then it's really easy to say, kubectl get builds and see a list of builds, and then you can manage those directly. But we're not, Kubernetes just isn't quite there yet, and we all kind of know it, and we're all kind of working toward it. So this is the best we can do with the tool today.
Yeah.
Is there any gateways that can do the opposite, listen out? So if I have Bitbucket, but I have an internal Kubernetes cluster that doesn't have a public IP, are there any gateways that can maybe listen to Bitbucket for certain events, like GitHub or whatever?
Do like a polling kind of thing. I mean, if if you'd like to make that, it's your chance to
Yeah.
contribute.
So the
but we,
question then to repeat for the people who are
oh
watching
yeah,
is
sorry, yeah,
is there basically can you write pull based instead of just push based hooks? And the answer that Luke just pointed out is yeah, you can. I know of a couple. Somebody wrote in an event processor one that listens, and there's a few like that that will basically go out and check and see if there's something new. Basically, with those gateways, as Luke demonstrated, you can code whatever you want. The only thing you have to eventually be able to do is kick the secret out into your Kubernetes cluster. So.
Yeah.
This is the last question. Very awesome. There's like two manual steps. There's like a draft up and a draft connect, and that felt like it was a pretty manual step. I was wondering if there's a way to have, or if it even makes sense to have something like a watch command, and at that point, if it would even be cost effective, because it takes on the order of 1 or 2 minutes to get that feedback loop. Does that happen behind the scenes? Could be 15 minutes, could be 30 minutes. Have you explored that? Because that would be a more seamless developer experience, and then it just alerts you when something's gone wrong.
So the question was, in the demo I gave, I did draft up and draft connect. Would it be possible to automate that to a greater degree so you could do, say, like a draft watch on files, and when they're changed, just automatically kick that off? And the answer is what you saw was my opinionated workflow because I like doing it manually. There is a mode in there in the draft.toml file where you just flip on and say, I want to watch this, and here's the pattern I want to use to watch this kind of thing, and then it'll kick it into that mode. There's also, I mean, I showed VS Code. I'm going to admit, I'm a VI user and I like the command line, so I'm not the right person to answer a lot of tooling questions, but I know for sure, because I've worked on it, that there's a VS Code draft plugin where you can actually, you don't have to run the terminal commands at all, right? You just basically trigger something and it'll do, again, I don't know what to do. You press a control sequence and it says, okay, I'm going to do a draft build and a draft deploy and stuff like that. It might be F5 or something like that. And I'm not gonna spoil anything, but KubeCon is coming up, and I have previewed the demo for draft that they're going to do there, and they are going to show an amazing level of IDE integration there with VS Code and open source and Visual Studio and stuff like that to show you, like, if you're the kind of Java developer who wants I'm sorry, that's a pejorative, right? If you're the kind of developer who wants like tooling all the way up and down the stack, there have been developers who have been out there working on that to make it so that draft is fully integrated into the IDE. So that'll be a good one to watch for if you're at KubeCon EU. Stop in for that, or otherwise watch for the video when that comes out. I'm not allowed to spoil the secret, though.
Cool.
All right.
Thank you.
Thank you.
Bathroom, and then we'll be back here. Corey will talk about cloud agnosticism. Theoretically, the theory of the discredited theory. Oh, you're thanks. Okay.
Test, test, test.
All right, let's get settled. We're gonna start the presentation. Don't make me whistle. You don't want to hear that. Try it again. How's that? It's on.
Can you hear me, Tucker?
I turned the switch on. Let's put it that way.
Hey, there's this third option there. How's that? Wonderful. That's why we test these things.
All right. So, wrap it up tonight. Corey's going to talk to us. Came all the way up from San Francisco to talk to us about the myth of cloud agnosticism.
Or so they tell me. All right. A talk on the myth of cloud agnosticism has to start with a statement, like cloud agnosticism is a myth. That's deep. I'd like to define my terms before I dive into this, because I'm sure no one is going to find any of what I say controversial, objectionable, anything. We're technical people. We don't tend to argue. We just agree and go along with the herd. Now, cloud agnosticism is something that a lot of people are talking about lately. The idea of being able to build and deploy workloads to multiple providers seamlessly. I mean, Kubernetes itself talks about this as a capability. And that's great, except for the part where I think the entire concept is largely crap. You start with multiple providers, for example, the big cloud providers and, of course, your dumpster heap of a physical data center. And okay, you design and build a workload that you can just seamlessly migrate between all of these. On paper, it's glorious, but what happens? That's right, it catches fire. No one likes that. Oh, you're not immune from that either. You catch fire. And then fire does what fire does. It spreads to the cloud, and then I'm on fire. That's terrible. Segue. Who am I? Great question. Glad I asked. I do a lot of things. Most of the time, I'm a consultant that solves one problem. I fix the horrifying AWS bill. In service of that, I tend to do all kinds of other weird things that are quasi-relevant. For example, I write a weekly newsletter called Last Week in AWS. I gather news from the Amazon ecosystem, strip out the boring, crappy parts that look like paid promotion, and take the rest and make fun of it. Sometimes less sarcastically, I now have a podcast that comes out every Wednesday called Screaming in the Cloud. Interesting conversations with people doing weird things in various cloud environments. In fact, I think I have someone from Azure joining me in the relatively near future. I'd also like to thank everyone here at Microsoft Denver for hosting tonight. This is fantastic. What? Sorry? Oh, we're in Boulder? Okay. And of course, thanks as well to Reactive Ops, basically solving the world's problems by pouring Kubernetes on them. They're sitting in the front row if you want to talk to someone about what working here looks like. If you're sitting in the front row and don't think you work for Reactive Ops, surprise, you've been shanghaied. Okay, so let's talk about 2012. Terrible movie, but if we think way back to it, the idea of being agnostic between cloud providers was a thing. Everyone wanted to be able to go in different directions. They wanted to hedge bets. No one wanted to go all in on one provider for a variety of reasons. Some valid, some ridiculous. And I was an advocate of it as well. It seemed like, well, there are some dangerous things that look like they have sharp edges here. And at the time, I would have told you back then, oh, don't go all in. There are reasons for it. For example, what if the provider you pick goes out of business? That's not a great situation to find yourself in. What if they just start cranking the price through the ceiling? That's something that was a big concern back then. And what if the people running our crappy physical data centers get angry as we start basically working them out of jobs? But in practice, and I'm comfortable saying this 6 years later, these things didn't happen that way. For example, most cloud providers stayed in business, with a couple notable exceptions, like Verizon's public cloud. They turned it off for 48 hours for maintenance over a weekend. Turning your cloud off for cleaning? Don't do that. And it turns out that over time, and we now have enough data to track this responsibly, prices go down. They don't go up. And that tended to reassure people as well. And it turned out that when I worked in data centers, I wasn't need to worry about revolting because I already was revolting. Yeah. Okay, now there's a decent chance that at this point you think I am completely full of shit. And you're not entirely wrong, but let me make my case a little bit. It's easy to say, but Kubernetes solves these things because you can seamlessly deploy things and send it wherever it needs to go. Those nodes, those clusters can be in different providers and things are great. And you're right, it works that way for the demo applications everyone talks about with this. See, we can deploy a WordPress blog in multiple different locations at the same time. Yeah, but that blog generally gets fewer hits than baby seals do. So once you start scaling, this becomes a problem. Companies have also started to think about this in different ways. In fact, there was a survey last year by some nice folks who might be sitting in the audience. And just shy of half of companies surveyed were only in one cloud provider. And then there's a diminishing long tail of people going frickin' ridiculous. 5+ clouds. I don't think I could name that many at this point. So I want a little bit more data to back this up. So as a part of my stupid sarcastic newsletter, at the beginning of this year, I launched a survey last year in AWS. And there was some interesting data that fell out of that as well. For example, it was neck and neck the entire time between whether people in AWS environments were using CloudFormation or Terraform. When I talked to people about this, the reason they said Terraform was always for the same reason, being able to deploy to multiple providers. How's that going for you? And then they just drank and drank and drank. So, okay, I feel like I should back this up a little bit about why working out of multiple clouds or building in this idea of agnosticism is fundamentally a crappy idea. For starters, if you want to be able to deploy to different providers at the same time, you're functionally limited to whatever it is that is common between those providers, which means in some cases that doesn't give you a lot. Instead of focusing on the things that help your business out, you're instead building things that they would call undifferentiated heavy lifting or global problems. Perhaps to put it a bit more on the nose for some people, sorry, there tend to be other challenges as far as, what do we do for a living? Maybe doing this other thing isn't the best use of our time. Let's also talk about the idea of data gravity. Namely, that where your data lives is generally where you tend to park everything else. And there are reasons for that. If you're in a situation where, yeah, we can save a bit of money on our container costs, but moving the data there is horrific. Pop quiz, we have some cloudability people here. What does it cost to move 1 gigabyte of data out of AWS into another environment? Any answers? 12 cents. Okay, no, close. The correct answer is nobody freaking knows. That's from the Open Guide to AWS. Yes, that is a real chart. Yes, that is mostly accurate as best we can tell. It's awesome. There are other business side problems too. For example, have you ever tried just moving enormous piles of money that you thought was going to go to one vendor and then, we're putting that to another vendor instead, and you don't tip off the CFO in advance? The reaction to that is not great. If you're lucky, they don't rage quit on the spot. So I floated this idea around a bit, and I did get some, well, actually comments out there. Oh, good. So before we go into the Q&A section of picking apart everything I have to say on this, great. Let me cut off some of that too. For example, a lot of places talk about, well, different providers have different things that they're great at. So why would we just take second best for everything else? In this scenario, you're right. You have a point. I'm not talking about never use multiple providers, go all in on one for everything. But you don't necessarily want to split it down at the workload level. Some workloads do not gain anything by being placed in other environments. There are edge case exceptions. I'm not trying to say this is a global rule. That's what best practice means. If you have a compelling reason to go a different direction, please do. That's why they're not laws. Sometimes people say, oh, so I should just go ahead and wind up giving all of my money to one company, and then they get very hurtful. That wasn't very nice of you, but I'm going to look past it and keep on soldiering on. There is validity to this. Generally, you don't want to have all of your money going to a single vendor because then you generally tend to lose negotiating power. When you're spending this kind of money, they're not your vendor anymore. They're your partner, whether you like that or not. Because when they're having a bad day, I promise, so are you. And this was always a popular one too. Specifically, great. Well, we don't really know like what our business model is going to shake out as, and what if Microsoft or Amazon or Google decide to step into our space and start doing the thing that we do? That was a valid concern, but you take a look at other companies now. For example, Netflix runs almost all of their cloud infrastructure on AWS. They also have Amazon Prime as their #1 competitor in many markets. The challenge there is, okay, you begin to see how they wind up doing some of this data separation. If it got out that Azure or GCP or AWS was scraping customer data to see what they're doing and then working around them, they would lose all of their customers overnight. I can't believe that any provider would be that risky at this scale. Now, maybe you're talking about the small provider you found down the street selling cloud services out of the back of a van. Okay, maybe there's going to be an argument to be had there, but I don't find it viable in this context. And the ever popular one, which is, okay, well, what if we do get a new strategic mandate? We need to move out of a particular provider. They've broken an SLA, contract negotiations have broken down. They tried to buy us, we say no, and now everything gets rebooted 3 times a day. Great. The challenge here is that this one, unlike most of the other things I've said, is valid. But if you try to build and maintain a level of agnosticism into your components from day one, 2 things are going to happen. One, it's going to take a tremendous amount of energy. And 2, you're going to screw it up. If you take a look at people who say, oh, our environment is cloud agnostic, great. Now go ahead and deploy it to a new environment as a test and everything falls over. It's similar to doing a DR exercise in some ways, where we have a DR site, so you do a DR exercise, and the first thing that happens is it screws up 20 minutes in. So you go back, you refactor, you kick off the exercise again, and this time you get it 22 minutes, and so on and so forth. As you iterate through, you eventually get there, and then, huzzah, we can fail over to our DR site until the next feature branch gets merged in, and then we're back at square one. People don't spend time focusing on this. So instead, they build it in aspirationally, but it doesn't work. And when the time comes, they still have a whole bunch of pain. What they give up in terms of feature velocity when they do this is far more damaging to the business than the amount of work it would take to actually do the migration when the time comes. Most of us generally are not writing in vendor-specific languages, if such things exist. We can take the things that we've built and port them between providers. I'm not saying it's easy, but it's not this impossible feat that has never been done before. I mean, ask nicely enough, they'll probably build you an AWS 400 to put your mainframe into someday. We don't know. It's not the sort of thing that I find that tends to play out. So, all of that said, it's now time for questions. Fight me. Tell me that I'm wrong. But before we do, a quick reminder of 3 things that are not questions. That's right, calling bullshit, while accurate, not a question. Neither is your resume nor a long, rambling, pointless story. If you want to put all 3 of those into one really short sentence, you could try something like, that's not how we do it at Google. And then you'll have all of it. So, questions, comments, thoughts? Tell me I'm wrong. You, sir.
So, one of the things that I've always found mysterious at my last gig, all the customers were like, hey, I want to be in multiple clouds. And I said the same thing that you did, like, okay, yeah, get real.
Mm-hmm.
How are you going to even monitor that and figure out what's wrong? And the question is, these big companies, they're all in with Cisco, they're all in with Oracle, they're all in with VMware. They all rant and rave about how bad it is. But they're still there, and they do it over and over again in their own data center. Why this obsession with cloud agnosticism? I mean, what's your experience? Why do they care?
Great question. Again, to speculate wildly, I think it takes many different forms. But what you see very commonly is the idea of If I buy a bunch of Cisco gear and Cisco gear tends to fall over, I have recourse, I can sue them, I can yell at them, but Cisco as a company doing something that displeases me, I still have my thing here that I bought. They're not going to be able to turn it off. It's going to continue working. Public cloud requires a tremendous level of trust that I don't think you see in that other model, which is you own everything. You own, like I'm responsible for my availability, but you can break it. That becomes a very different model that a lot of people are uncomfortable with. I think that's largely what's driving it. There's also the optics perspective. For example, it just came out earlier today that there's a big bidding project going on for a Department of Defense cloud, the JEDI system. Yeah, great naming there. Where did you come up with that one? They were going for a single vendor solution, and people have been whining and crying about that because, okay, great. What is, so they said, we're going to do a second version of the RFP, and they did, and almost nothing changed. The challenge here is that it looks kind of shady when you say, I'm going to give an enormous pile of money to one company, and if we decide we don't like dealing with them, there's no call them up and tell them to stop. It's like, I'm getting the hell off of your service in only 18 short months. It does, and that's optimistic. You're stuck with whatever provider you pick for a while. If you're not willing to make that trade-off, you're probably still in the data center to some extent. But the idea of being multi-cloud feels like a mitigating factor, even if it's stupid. Hopefully that answers your question. Howdy.
There's like another flavor of multi-cloud.
Mhm.
I'm not sure. Maybe this talk isn't aimed at that. But, bigger companies, they end up. You might be in a situation where you have 3 different clouds because you've got 2 acquisitions, right? So you've got relatively siloed, functional, profitable business units.
Yes.
And they're working in different environments. And what you're trying to do is work towards some sort of agnostic underlying infrastructure to bring those things closer together over time. And it's not necessarily a turnkey solution for the whole company where everything's in the awesome future.
Right.
So I'm just wondering if this pertains to that, or if it's more about this saleable concept of we've got something that'll run on any cloud. And it's not really realistic, maybe.
Right. There are 2 ways you can go in those scenarios. The first is, okay, we bought a bunch of things on different providers. They're clearly different workloads, so it's okay. We have this one on that provider and that one on another. And that's a very valuable strategy. If you want to consolidate and bring everything closer together, you're probably going to want to move at least one of those workloads to something else. Otherwise, you're going to do what I mentioned a little earlier, and we're going to build our own cloud agnostic layer that acts as a provisioning shim. How many times have we seen that in the world? And they're all terrible. You even saw, to some extent, a lot of this with OpenStack back before Kubernetes decided to pretty much murder it. And now you're seeing companies at least approaching it from a perspective of, we're going to do this with Kubernetes, as opposed to we're going to write our own crappy thing, turn it into a pun based upon our company name, and then I'm sure the world will adopt this. It doesn't work that way, unfortunately. Now, corporate strategists do what corporate strategists do, and generally speaking, you get a new CIO in whose average tenure is something on the order of 18 to 24 months. Sitting there and keeping everything going with a status quo is not the stuff that resume builders are made of. So it's time for a migration. You can always have things go out. You can have things come back in. That's an incredibly cynical perspective, but it does tend to drive a lot of the decision making. That's why you see all these giant companies that specialize in this, advertising in airports and in flight magazines. So. Okay, yeah. Sorry for the microphone. It was that Kubernetes didn't kill OpenStack. The vendor pyloned it. Yeah, that's fair. And I'm starting to worry with all the vendors pitching into Kubernetes. Are we about to see the same thing again? Because you see all of these giant enterprises from 1990s tech, and they're all involved in the project. I don't know what other people's reaction is, but mine isn't, I bet that code is going to be awesome. It tends to be, oh dear. I mean, when you see an acquisition by some companies, and you think, oh, good, that's going to go really well for them. And the rest is, well, pour one out. Because who buys a semantic product on purpose? It becomes a very different story. And I think you're seeing the same thing here. I think that the Cloud Native Computing Foundation is doing good work as far as being responsible and reasonable stewards of the Kubernetes project. I don't think this is the next OpenStack yet. But we'll see. Because don't worry, I'm told that serverless is the future.
Yeah. So I have a 2-part question for you.
Oh boy.
You're at the Kubernetes Colorado meeting, so you're in Denver County.
Okay.
Maybe a little Fort Collins.
Okay.
If you're lucky. little 4 columns if you're lucky.
Hmm.
So first question is, how do you see Kubernetes reshaping this cloud agnosticism approach? First
Mhm.
part of the question.
Sure.
And then second part, what about the open source community kind of contributing to that? The Minios of the world who actually come in and say, you know what? The world thinks that a tissue is a Kleenex, so we'll go with S3 storage, but we'll abstract that with an Azure blob storage concept behind it.
Mhm. I think that first off, we're seeing that Kubernetes is at least making it palatable to move a workload. You don't have to, and containers as well have also played into this. It's no longer having to build bespoke provisioning systems to build an AMI. And yes, it is AMI, not AMI. I don't care what those Amazon people say. They are wrong. 88% of my survey respondents agree with me. Now, so you don't have to. You can now abstract that away and have a container or something similar to it that runs anywhere, and that's great. But there are still network security challenges. If you have another service you need to talk to, for example, DynamoDB, do you want that going back all the way across a VPN to introduce the latency that requires or the complexity of setting that up? It's one of those areas that starts to get very deep very quickly and very application workload specific. The danger part of that is it becomes, well, it depends, and everyone sort of fragments off and goes their own way on that. You don't see those demos. That's not conferenceware. That's the nitty-gritty of actually doing operations for a living on a day-to-day basis. It's not one of those things where you're going to get up on the stage at reInvent and go, tell us about your migration to the cloud. It was awful. I mean, no one wants to tell that story. Everyone wants to get up there and pretend that everything was glorious. And like you're sitting there going, wow, I would love to see a project that went that way. I work there, and the story they're telling didn't happen. It becomes this sort of washed over version of what really transpired. As far as the open source community pitching in and starting to help shape this in different ways, I find the exact opposite generally. I find there tends to be a forking, a fragmenting. Everyone has a really neat idea that works for their specific use case. Like the old example I like to use was configuration management. Anyone can, as a toy problem, build their own configuration management system that solves their problems. It's when they map it to other styles of workloads, how other companies do things, it's, oh dear, it turned into a mess very quickly. So when you see the prominent leaders step into that space and everything else tends to fall by the wayside, you still wind up in a scenario where people are coalescing around certain ideas. I don't think we're at that coalescing moment yet. I think there's a lot of debate about how to handle these things. You take a look at what is being containerized and what Kubernetes is being rolled out to achieve in a variety of companies. These workloads are very different in some cases, and they tend to be still experimental or development in some cases. I mean, which is great. You don't generally want a 150-year-old bank to be diving into the new thing as fast as you can get it. Oh yeah, if you're not using Azure functions to wind up doing all of your ATM network stuff, oh, you're behind the curve. No, how about we don't riot in the streets today because everyone's balance is down? So does that answer your question? I feel like I've danced around it, but I may not have gotten the exact. Okay.
Sounds like Pied Piper's got the solution, right?
Oh, absolutely. Fund my startup. Yeah. Oh, geez, this guy.
So, I mean, I know that you think about the serverless future that's coming.
Oh, yes.
So once we're there, and be that Lambda or Azure functions or Google Cloud functions or, kubeless or something inside of Kubernetes,
Yeah.
once we're truly in a serverless world, does
Yes.
cloud agnosticism become more of a reality?
My version of that is absolutely not. If you take a look right now at existing serverless systems, and I've done a lot of work with Lambda. I haven't really touched the other stuff, so forgive me. Sorry, Microsoft. I'm going to tell the Lambda story instead. But you take a look at what people are using Lambda for and the events that trigger these things. Very often, it is internal events for the cloud. For example, an instance has come up, a disk has been provisioned, an object has appeared in S3. Those events are extremely specific to the provider in question. So as long as you're still using it in that context, yeah, the code you wrote can be dropped in anywhere. But if I'm running in an Azure function, it has no concept of an S3 object appearing and how that's going to be contextualized. Oh, it does now?
It has an
External events can trigger this now. How does that object showing up appear? Is there a Lambda function that fires something off?
via webhook or just a general post call.
I wasn't aware S3 objects did webhooks. Huh.
External object event.
Awesome. Well, that just broke my metaphor in half. No, it's fine. You could extend that out to DynamoDB events. You can extend that out to SNS or SQS style. Sorry, SQS is not a trigger yet.
Much like all the things around you.
Yeah.
SOP is growing.
Yes, indeed. Oh dear. Yeah. No, the challenge too is my point is that if you see what these workloads are, they're very provider specific. For example, I write a bunch of Lambda functions that apply tags to things. Well, that structure and how that's conceptualized and how that's done vary from provider to provider. I had a client who was multi-cloud, and I rolled out some functions to do AWS tagging, and they put a stop on it for a little while because this won't work if we roll it out in GCP. Right. You get that I'm here to fix the AWS bill, not the other things that you're doing. All the abstractions are different. It doesn't work the same way. But there's still the reflex is everything must be completely agnostic. That's great, but it does limit your velocity in most cases. It also means when a new provider rolls out a new feature that really benefits you, you may not be able to take advantage of it. Yes.
I'm wondering if you've looked at all at the Open Service Broker API and if that changes this conversation in any way, given that it can abstract things like Dynamo and like Cosmos DB, and from an application standpoint, they can interact with those two different services the exact same way with the exact same events being sent and received.
I've not heard of it now, but hearing that, my immediate question is, okay, what are the trade-offs that are being made? Is it lowering it to a baseline of common features between them so any differentiation gets lost? Are you introducing latency to the specific calls for many workloads? That's not acceptable. There's no silver bullet in this space. We've seen it in various providers again and again, and this battle's been fought many times in the past and will be fought many times in the future. I think it's a neat idea. I'd be very curious to see whether it gains traction. And
it's absolutely gaining traction.
Yeah.
Like, I mean, just today at the Cloud Foundry Summit, both Google and Microsoft announced huge amounts of support for the Open Service Broker API. And pretty much every service across both of those clouds now responds to Open Service Broker API requests. So I think we're getting closer. I agree that we're not quite there, and I completely agree with where you are right now. But I think we are trying to fix this.
Right. I mean, I guess a real easy example would be something like Google's Cloud Spanner. The idea of a global spanning database that basically mimics ACID compliance. It shouldn't exist. And it's great, but there is nothing else like that out there. So even if you wind up being able to abstract away the API calls, if you're leveraging a service like that, well, how do we build a world-spanning database on a different provider? You generally don't. I mean, it's one of those time to re-architect the application itself. Now, I tend to be enough of an agnostic when it comes to cloud. I would not build my the application that makes money on top of a service like that as long as there is not a viable exodus path in theory. Whether or not I would actually build that function in to roll it over to something else, I don't think I would. But at least in the back of my mind, if everything turns against me and Google pulls a Google and yeah, we're going to be turning that off this month, then I'm going to be able to fail over to something else that, at least in my mind, gives me a strategy forward. Without that, you're more or less just really hoping the vendor decides to continue supporting the thing. And not to pick on Google too much here. This is something that, and then there's a single vendor. This always becomes a concern. Yeah. Sure.
About the cloud agnosticism.
Sure.
One of my philosophies, when dealing with people and trying to understand ecosystems, is what are the incentives of the vendors? And so as much as some of these APIs and other things to get cloud agnosticism are out there, none of these vendors really want you to be able to move away from their cloud.
No.
And their incentives are all wrong. And at the end of the day, it's not provisioning that's the hard part in multi-cloud. It's actually the data path. I mean, if you're not running the same code, even if you have a MySQL interface to a different backend database, good luck making that work in every case because you're probably dependent on very particular behaviors of each of those APIs and the implementation.
Yeah.
And my experience is that that's actually the real problem, not provisioning. It's like, well, but the service isn't the same code, and therefore it breaks here and works there. And that, to me, and by the way, nobody has an incentive to fix it because they want you to be locked into their platform.
Right. For example, AWS offers a service called Snowmobile, one of my favorite things. 100 petabytes of drives on the back of a tractor trailer, hurtling down the freeway. You fill it up, they bring it into a data center. You notice they always tell that story, not the, we'll fill it with data and then send it to you.
They do that though. I looked into it.
They do indeed, but they don't advertise it. It's very quietly hidden in the back. It's, I mean, again, it's like they always tend to tell stories a bit differently than I would. For example, there's half-price data transfer between the region in Ohio and the region in Virginia. They said yes because we have an ultra-fast, private, low-latency link instead of the real story, which is even data wants to get the hell out of Ohio. Yeah, their storytelling could use a little bit of work.
If I have power at my house, I have to move to get another provider.
Mhm.
If I want free heat, maybe I move to Iceland and just pop a geyser open next to my house. So when you go into a place, do you just encourage them to double down? Like, just keep using AWS, but do it even better. I mean, that seems like what you would say versus like, no, figure out how to get to Azure and GCP too.
Right, and that's often asked of me of, okay, we're looking at the cost. Should we migrate over to insert cloud provider here? They'll give us a bunch of credits for free is usually part of the story as well as part of that too. That's great. I mean, any good drug dealer will give you the first taste for free. Come on. Keep going back in line for free samples, they catch on. But this may be Sam's Club I'm talking about now. Anyway, the challenge with this approach is no provider is perfect and you're always going to have challenges with it. Picking up and leaving that provider entirely, first off, is generally not a trivial task. So I want to see a business reason for it that extends beyond, well, they didn't buy me a nice enough dinner when I was out visiting with them last time, so I'm thinking another vendor might, or someone else will buy me on a flight to Japan or something. It's not the interesting part of the story. There's a reason that people want to leave, and a lot of times it's the grass is greener syndrome. I don't think that, as a general rule, a cloud migration makes sense in that context. Often it does make sense to start taking some workloads and spinning them up in other providers. First, just to have an idea of what else is up there. It also is surprisingly handy when contract renegotiation rolls around of, well, we were considering migrating these other workloads too. I'm not saying that you necessarily bludgeon your vendors to death, but by the same token, reminding them that, yeah, it's a giant pain to migrate off of you. It's not impossible is always a theme that's sometimes handy to bring up. I just don't advocate doing it at the expense of your own feature velocity. Other questions, comments, calling me out, etc. Yay.
We're in Colorado where level 3 is homed, and these guys were masters at this game. They actually had a small data center running all the competitors' equipment. Mysteriously, never told you what it did, but every sales guy, Cisco sales guy, went by the Force 10 rack. Force 10 sales guy went by the Cisco rack. You know, and it may be worth doing that if you're a bigger company. Make sure you have some apps in that other cloud just to, scare the vendor. Like, oh yeah, we've got that app running in that other cloud over there.
Yeah. The counter argument too is that none of the cloud providers are stupid. They're like, oh, okay, you have a toy WordPress blog that I can make a horrifying metaphor about. Great. Yeah. Meanwhile, the thing that actually makes you the tens of millions of dollars a day, yeah, okay, you're going to move that? Great. Let us know how that goes. I mean, vendor management is its own discipline.
Yeah. You have to make it convincing, of course.
Yeah, it generally helps. But, I mean, sometimes you can see the amateur attempts of putting other vendors' stickers around the office. Engineers like to do that. It's, oh, honey, you've got to go a little better than that. Like, add one of their top-performing VPs on LinkedIn. That starts to get people wondering. Other questions, concerns, criticisms? Oh, perfect.
So I'd have to notice there's, like, one specific thing that I tend to notice for your argument is that if you're a developer, you know how to use Docker. If you're a developer, you know how to use Kubernetes. You're not going to learn this one proprietary software, one vendor, because you don't know how to use it because it's not free. If you want to host your blog in Amazon on, KAS, it's going to cost $70 just to do a simple little blog. So people only know what they know, which is the tool they know. Therefore, if they go into cloud, why they want to be cloud agnostic has nothing to do with Azure. Has more to do with that's what they know how to do. So I think that's more the point is when developers come into saying which cloud you want, it's more like I want this one because I understand it.
Yes.
Or I don't trust that one because I can't run on my computer. And so it's the same thing of why, everybody's trying to run AKS everywhere. So to make a comment, why?
No, you're absolutely right. AKS is awesome. EKS, the Amazon version that they advertised at reInvent, no one's seen it. It's one of those, well, it might be awesome, it might be terrible, no one knows. So it's, yeah, okay, you made a statement, but can we actually trust it? I don't buy futureware. And you're right, I think there is a strong bias for working with the things with which we are familiar. Counterpoint, 5 years ago, Kubernetes didn't exist. There wasn't I can still say that 5 years ago, right? Okay, good. Yeah, it's time is speeding up on me here. Yeah, it's one of those areas where everyone had to learn sooner or later, and you still wind up with the grouchy, grumpy old data center sysadmin types. Where it's where they refuse to use anything that isn't Solaris, and they're finding jobs harder and harder to come by. I mean, eventually you do have to keep up in this space. But you're right. I'm not particularly interested in learning the ins and outs of every provider's proprietary systems. And I just point out how weird it is to be sitting here having this conversation in a Microsoft office. You told me 20 years ago I'd be doing this. I wouldn't have believed you. Ooh, there we go. I mostly just came here to complain about the Mac for Office auto updater. Wrong group? Yeah.
Totally wrong group. They told us when we got acquired, we were all kind of pumped about Microsoft. We're like, we should get a sign out, and they're like, don't do that. People just start walking up. Can you fix my Xbox?
Yeah. Perfect.
Do we have any other quick questions? All right. Anybody have any announcements? First, let's thank Corey. That was
yay for me. Yeah,
anybody have any announcements they want to share before we call it a night?